Hi, my name is Craig DeClerc, and I'm a member of Dr. Lick Schwan Lee's Computational Biomechanics lab. This tutorial is a walkthrough of the segmentation process, which starts with magnetic resonance images, otherwise known as MRIs, and finishes with a three-dimensional mesh that can be used in an assortment of cardiac research. The first thing we are going to talk about is the software needed to complete the segmentation process. All the software used to complete the segmentation process is open source and can be downloaded from the internet with no cost. If we open Google, the first software that we use for segmentation is MeVisLab. So if you go to their website, you can hit download, pick the specific version that you want, and the specific operating system you work with, and download it on your own personal computer. The second software we use for 3D modeling is called ParaView. So just like MeVisLab, you can Google ParaView, hit download, find your specific system requirements and the version that you prefer, and then download it as well onto your personal computer. So to start the process, we're going to open MeVisLab, our main segmentation software. This pop-up window comes up, you can just exit out of it. So up at the top left, what we're going to do is open, well, it's just this file right here. So one left click on that. So in the research drive, you can go scroll all the way down and then open the segmentation 21 January 2017 and double click that. And that will open up the segmentation network. The main box that we're going to be focusing on in this segmentation tutorial is the calculate volumes box. Within the box, you'll see all these different boxes that we call modules. Each one you can grasp and move around. And actually, each one is connected to each other through these little guys right here, so you can actually disconnect and reconnect them, but I don't suggest doing that. So the first step in our segmentation process is we're going to open up an MRI image. So to do that, you're going to go over to DICOM Browser 10 right here, double click, and that's going to open up a window. You can hit browse, and then you find the specific MRIs that you want to use. So in this tutorial, I'm going to go into our research lab, open up MRI, pulmonary hypertension. We're going to look at case MR17. And then when you get to the MRI page, if you double click, you don't want to go that far. So you just want to highlight the MRI and hit select folder. And that should come up. So the file names that you're looking for is LVSA or SAX, which either stand for left ventricular short axis view or short axis view. So once you get there, you can double click and then exit out. Our next step is to go over to subimage 5, which you can double click. Another pop-up box comes up and you're going to hit full size. Then we go over to Gauss smoothing and hit update. So once this procedure is done, we can go over into our region growing macro right here, double click, and we can find our image. So at this point in the video, I'm going to just share the shortcuts and how to navigate throughout the MRI image. So as you can see, as of right now, it's just a black image. But if we right click and drag our mouse over, you can actually change the brightness, and you can find a brightness that's sufficient to use. I usually like to go about right here. So once you have that, you can see our heart. So at this point, I'm going to share how to go up and down. So to move longitudinally throughout the heart, you're going to use the up and down arrow keys. So that will go all the way up and down the individual. And you can see the ventricles right there. And then if you use the left and right mouse, you're actually changing the time point. So you're actually moving with respect to time. And you can see that being done here. So if you go up, if you hold down the left key, it scrolls all the way down, and you can actually see a full cardiac heartbeat. Some other things that are good to know, you can use the scroll wheel to move up and down as well. If you hit Control and press down on the scroll wheel, it's another zoom tool that you can use. If you hit Shift and press down on the scroll key, you can actually move the whole MRI around. Same thing with moving around the segmentation file. To move around, if you push down on the segmentation wheel, not the segmentation wheel, the scroll wheel, you can actually move up and move the whole network. And if you use the scroll wheel, you can zoom in and out. So we're going to go back into region growing macro. So what the region growing macro tool is going to do is help the segmentation move quicker. So what it does is you plant these things called seeds or seed markers on the ventricle that you want to segment. So this being the left ventricle, this being the right ventricle. So if you place seeds and you go through on each time point and place them, I usually move with respect to time and place them on every single ventricle at each time point that I want to segment. So the seed markers automatically project through the z-axis. So you can, if you place them, I like to place them usually higher up, and then they automatically project down, which I'll show you in a little bit. So once you place all your seed markers, you can hit update, and it'll automatically load and segment your ventricles. Here it didn't work, or it didn't segment anything because it didn't pick anything up. So if you actually lower this threshold right here, say to 150, and update, you can actually see the volumes increasing and it's segmenting automatically. So it looks like that's done. And you can see I'm staying at time point 0. And if I move down the slices right here, you can see that it automatically projected downward. That's moving through the time points. So as you can see, the region growing macro is not perfect, and it's going to miss some areas within the segmentation MRI file. And so that is what the researcher is there for, to fill in these spots and make it accurately model the different ventricles. So once you're done with that, you can exit out of the region growing macro. And then we're actually going to go up to view 2D6. And this is the same thing. You can change the brightness to your liking. And then you can see the different files here. So now what we use is Draw Objects 3D. If you open that, another pop-up window shows up. So if you look here, this 1370 is going to be your right value, or the thing that draws on the picture. And then any other value, say 0, is going to erase. And then this voxel size is going to be the size of your so-called brush. So you can do 8 by 8, or you can do, say, so 8's going to be like, oops, if you use 1372, 8's going to be like that size. If you go 15 by 15, it's going to be that size. 20 by 5, look like that. So you can kind of see how this works overall. So your process, what you're trying to do is accurately model and fill in any gaps that you see in the ventricle. So you would go in and actually manually segment, which takes the longest amount of time. And that's why that region growing macro is so helpful. So we can just change our brush here. I'll go through a few different time points just so you can kind of get the general idea. So this 1372 value is going to be different for every different MRI you're using. So I would definitely suggest writing that value down right when you start the segmentation process. So I'm going to change my brush size back to 8. Go around. And segment each different layer. So when you're doing this, you'll actually go through every different time point and make sure all of them are good. And then once you get done with all those different time points, you'll actually move down a slice and you can do all those, and then move down, do all those, and then see sometimes the macro actually overestimates, so you'll have to take that into account and actually erase what it's doing. So it takes a little time, a little mouse skills, but eventually, once you have all that done, that's definitely the longest part, so that's definitely a hurdle that you get over. So within here, it's okay just to exit out. So say if I exit out of this and then open it back up, it's gonna put me right back in the same spot with the exact stuff I did. So you can just exit right out. So say that we're completely done segmenting our MRI. To save that, we would actually go over to Image Save, double click, pop-up box. This browse will let you place the file anywhere you would like. We can put it in MRI 17. So we did the left ventricle, or a little bit of the left ventricle. So we can call it left ventricle test. And then we can save that file. So make sure you do hit the save button. If you don't hit the save button, it will not save correctly. So once you're done, you can exit out. And then next thing that's very helpful is you can actually calculate the volume at each time step. So go over to calculate volumes, hit update, and then you can actually see those through the print curves. And it will tell you the volume of the ventricle at each specific time point. So you can see those. And then the same thing, browse to pick where you want to save it. And we can call this LV test once again. And again, hit save. So once that is all complete, what you can actually do is generate our 3D surface. So to do that, you're going to go over to the left side of the Calculate Volumes box. You're going to see the WE meso surface. And you can actually take that triangle, drag just like we talked about earlier, and drag it over to the Draw Objects 3D. And if you actually double click on that, you can pick what exact time point you want. So say 11 and apply. Exit out. And if you hit this square, and actually apply. So once you have it saved, you can go up to WEM Save, double click, and again, browse a specific place you want it to be at. And then so say we can save it as LV test once again. It already exists, we'll replace it. And then hit save. So now if you saved your work and you want to come back and work on it, what you would use is the image load function module. And to do that, the main important thing to worry about is this switch. So if you double click on this switch, it's either going to be, there's number of inputs, there's 2 inputs, and the active inputs are either going to be 0 or 1. So if you can see, if you plug in 0 and you follow the active triangle on the switch, it actually connects to the region growing macro, which then goes up and projects onto view 2D6. But if you press 1, you can see that the triangle switches and it actually goes over to the image load file. So if you go up to the view 2D6, you actually won't see any segmentation done on it due to the fact that it's not pulling data from the draw macro right here. So just to give you a few examples, we can open up the MRI 17. So if we open up an LV and load file, you can go right up here and view it, and you can see kind of a completed segmentation. I'll just go through these real quick, kind of give you an idea. So that would be the left ventricle. And if we come over here and we can load the right ventricle, if we load that file. and so that's going to be the right ventricle. So if you load your image, all the same operations still work. So if you still need to edit your file, you can still work on it. If you see that it's loading pretty slow, like it's not updating quickly, you can always make sure that this WEM meso surface is not attached. So just by just dragging this out, and that will make the process load much faster. And the last thing I'll open up is the epicardium. So the LV, the RV, and the epi. So image load 5 once again. Hit browse. We can load that file in. And so you can see the epicardium right here. So now we'll transition over to pair view. So we'll minimize that. We'll go over and open pair view. And another pop-up screen comes up. You can just exit out. If we go over to open, we're going to go over to desktop, MR17, and then wherever you saved your 3D files, you can open them up. So if we open up the LV, and so when you open a file up, it'll show up over here in this pipeline browser, and then all you have to do is hit that little button right next to it to be able to visualize it, and you can see our 3D left ventricle. So we'll go over and open the right ventricle as well. Again, same deal, hit the little eye, and you can see both of them together. And you can actually project the epicardium on top of both of those and generate that. So once you have this, you can apply, you can hit solid color just to see. You can actually change the opacity and see the ventricles inside the epicardium. If you need to make a cut or anything for your different coding that you're using, you can come over here to the slice function, project it in the Z normal direction, and you can actually cut wherever you want. So that's the segmentation process. Once again, my name is Craig from Dr. Lick Schwan Lee's Computational Biomechanics Lab. Thank you very much.